Hey everyone, welcome back to the channel. If you ever wondered how machines can understand words, images, or even audio in a meaningful way, then you're in the right place. Today, we're diving into key concepts in machine learning called vector embeddings and learn how they're transforming the way we build smarter, faster, and more relevant search experiences. My name is Mikhail Weinstein, and I'm a solutions architect here with Amazon Web Services, working with healthcare customers and focusing on search workloads. And today, I'm going to talk about the vector embeddings approach for search workloads and how you can use them to build intelligent search solutions. So let's go over a couple of basics. In machine learning, embeddings are numerical representations or vectors of data like text, images, sounds, or just objects in a multidimensional space. Think of them as a way to translate information into a form that machine can actually work with and understand. These numeric values are used to map elements in relation to each other in a multidimensional vector space. That might sound complex, but once mapped, similar things are placed closer together in a multidimensional space, and the proximity becomes an indicator for contextual relationship. Let's take a simple example. Imagine the words coffee and tea and astronomy in a simple 3D vector space. They might look like this. Coffee, tea, and astronomy having own vector representations as shown in this example vector space. Coffee and tea are close together in all dimensions because they're both beverages. Right, well, that makes sense. But compare that to a word like astronomy, which would be a way further away in vector space because it is somewhat unrelated. This spatial relationship lets us measure semantic similarity, which is incredibly useful in search and recommendation systems that we build today. Okay, so how does a text or an object in different modalities actually get converted into a vector? Well, let's look at the text or document as a simpler example. New York is a financial hub of the world. Beijing is the capital city in China. Even though these words are different, the model captures their contextual meaning and places them near each other in a vector space, as shown in these embeddings. One way for generating the embeddings is using algorithms like word2vec, glove, or faster text. These algorithms give each word a fixed vector, the same vector no matter where the two words appear in a document or sentences. There are newer methods, such as embeddings, GPT, and other similar deep learning models can give us contextual embeddings, meaning the same word can have different vectors depending on the context where it is being used in a sentence. Okay, once you got the embeddings, where do you actually store them? And once stored, how do you find these relevant documents or objects? And also, how do you do it fast? Well, you store vector embeddings in a special type of a database called vector database. A good example of a vector database is OpenSearch, where you store vector embeddings to search the closely related objects quickly and efficiently. Now that the data is stored in the database, how do you actually search? Well, we apply the same technique. A query is turned into a vector using the same embeddings method that was used to generate vector representations of our documents. The database compares vector embeddings to all stored vectors using distance metrics in a vector space like cosine similarity or Euclidean distance, and brings back the documents with the closest matches. Now that you have learned about embeddings and vectors, make sure to check out our next video on how to use Amazon OpenSearch service as a vector database. You can find the link to the video in the description below. Hope this video was useful and see you next time.